8 billion people, one planet, one countdown. 3, 2, 1, jump. Picture it happening. Every human being alive, all 8 billion of us, somehow gathered into one impossible, planet-spanning crowd, shoulder to shoulder, counting down together. The largest coordinated physical act our species has ever attempted. It should shake something. Register on every seismometer on Earth, maybe nudge the orbit, just wobble the rotation, just slightly, just enough to notice. 8 billion people jumped together. Earth moved less than the width of a single atom. That's not an exaggeration for effect. That's the actual number. And it's about to get stranger the closer you look at it. Here's the part of the popular idea that's actually true, and it's worth giving credit where it's due before the deflation begins. Newton's third law says that when you push against the ground to jump, the ground pushes back against you with equal force. Scale that up to 8 billion people pushing simultaneously, and Earth genuinely does push back against all of them at once. By conservation of momentum, technically the planet recoils in the opposite direction. This isn't a myth being busted from zero. Something real happens. The myth isn't that nothing happens. The myth is about how much. So here's the open question worth sitting with for a second. If something genuinely happens, exactly how small is small here? Smaller than a millimeter? Smaller than a grain of sand? Or something so far beneath anything you could picture that the comparison itself starts to break down? Momentum conservation works like a seesaw between two objects. Whatever momentum one side gains, the other side loses an equal and opposite amount. But how that momentum translates into actual movement, actual displacement through space, depends entirely on mass. A light object receiving the same momentum as a heavy object moves much farther, much faster. A heavy object receiving that same momentum barely shifts at all. This is where the numbers stop feeling abstract and start feeling almost absurd. Global population sits at roughly 8.2 billion people as of 2026. The average human body mass comes in around 62 kilograms. Multiply those together, and humanity's combined mass adds up to somewhere around 508 million metric tons. Say that number out loud, and it sounds enormous. 500 million tons of human bodies, all pushing against the same ground at the same instant. Now put that number next to Earth's actual mass, approximately 5.97 times 10 to the 24th power kilograms. Write that number out in full, and it's a 597 followed by 22 zeros, give or take. Humanity's entire combined mass represents roughly 0.00000000000085% of that number. As a fraction, that's about 8.5 times 10 to the negative 17th power. There's no everyday object that captures that gap in size. Comparing humanity's mass to Earth's mass isn't like comparing an ant to a mountain. It's closer to comparing a single grain of sand to every beach on every coastline of every continent combined. And even that comparison still understates the actual gap by an enormous margin. Here's where the deflation really lands. Physicists and science communicators have run this exact calculation repeatedly since at least the mid-2010s, in direct response to the same viral meme resurfacing again and again across different platforms and different internet generations. Every time, the math comes out the same way. Earth's resulting displacement from a globally synchronized jump falls somewhere in the range of 10 to the negative 21 to 10 to the negative 23 meters. Put that number next to something you can actually picture. A single hydrogen atom measures roughly 10 to the negative 10 meters across. That means Earth's theoretical displacement is smaller than the width of a hydrogen atom by a factor of over 10 trillion. 10 trillion! Not 10 times smaller, not 1,000 times smaller, 10 trillion times smaller than the smallest object most people have ever heard described in physics class. Sit with that gap before moving on, because it's easy to let a number that large slide past without actually registering. Here's a way to make it concrete. Picture a mosquito landing on the deck of an aircraft carrier, resting there for a second, then flying off again. By Newton's third law, the carrier technically experiences a force and technically responds to it. That response is real, measurable in principle, governed by the exact same physics as any other collision. And it is also so far beneath any instrument's ability to detect that saying the carrier moved is technically true and functionally meaningless in every practical sense. Humanity jumping against Earth is that Mosquito story scaled up by a number so large it stops meaning anything intuitive. The physics is identical, only the scale of the mismatch has grown. Here's the failure chain in full, because each step compounds the last in a way that makes the eventual conclusion feel almost inevitable once you walk through it. It starts with mass. Humanity's combined mass, while enormous by every human standard, sits at that infinitesimal fraction of Earth's total mass. Conservation of momentum, applying with total indifference to how impressive 8 billion people sounds, distributes the resulting displacement almost entirely onto the smaller mass in the equation. That's you, not the planet. Your body moves upward noticeably by however high you jumped. Earth's corresponding shift gets divided by that same extreme mass ratio. And the number that comes out the other side is the 10 to the 21 to 10 to the 23 meter figure already on the table. That displacement number falls many orders of magnitude below the size of a single atom. This is where the effect stops being merely small and starts being physically undetectable by any known measurement instrument. Not hard to measure with today's technology, not beyond current instrument sensitivity, but theoretically measurable with future upgrades. Undetectable in a much more fundamental sense, because the displacement sits so far beneath the scale at which matter itself is even organized into discrete, locatable particles that the question of where exactly did Earth move to starts losing coherent meaning at that resolution. Compare that theoretical shift to what naturally happens on Earth every single day, and the gap widens even further. Real earthquakes, measured on the Richter scale between 5 and 9, produce ground displacements measured in centimeters to full meters depending on severity. Ordinary tidal forces from the moon, happening continuously twice a day, every day, cause measurable millimeter to centimeter shifts in Earth's crust as oceans bulge and recede in response to lunar gravity. Even routine traffic, construction, and atmospheric pressure changes generate vibrations that dwarf the jump scenario's theoretical displacement by unimaginably vast margins. Any hypothetical movement caused by a global jump wouldn't just be small next to these natural phenomena, it would be permanently, instantly indistinguishable from ordinary background planetary noise, buried underneath signals that are themselves already considered minor on a geological scale. Earth's crust shifts more from a single passing truck on a nearby highway than it would from every human being alive jumping in perfect unison. Here's the third link in the chain, and it's the one that closes the loop entirely. What happens when everyone lands again? The exact same momentum transfer occurs in reverse. Whatever infinitesimal push Earth received during the jump gets exactly canceled out the instant 8 billion people return to the ground and transfer their falling momentum back into the planet. The system isn't just self-correcting, it's perfectly, mathematically self-correcting, because momentum conservation works both directions with total symmetry. Even the theoretically real, unimaginably tiny displacement that occurred during the jump has already reversed itself by the time everyone's feet touch back down. There's no lasting consequence whatsoever. Not a lasting consequence too small to matter, an actual zero net effect once the full up and down cycle completes, because the physics that pushed Earth one way during the jump pulls it back the other way during the landing, with the same precision, the same completeness, and the same total indifference to how symbolically significant the event felt to the people participating in it. A viewer might reasonably push back here with a clever workaround. What if the timing mattered? What if everyone jumped from the exact same side of the planet, all facing the same direction to concentrate the force rather than spreading it out? Or what if the jump repeated thousands of times, building up some kind of cumulative directional drift over repeated cycles? Neither workaround changes the underlying math at all. Synchronizing everyone to the same side of the planet doesn't alter the fundamental mass ratio driving the calculation at all. The displacement still gets divided by the same overwhelming mass difference between humanity and Earth, regardless of geographic arrangement. And repeating the jump thousands of times doesn't accumulate anything either, because each cycle, down, up, cancels itself out completely before the next cycle begins. There's no ratchet mechanism hiding in the physics that lets repeated self-canceling pushes build towards some larger net effect. Each jump and landing pair returns Earth exactly to where it started momentum-wise every single time, with mathematical precision. Throwing a single grain of rice into the ocean captures the same underlying principle in a different context. The physics of displacement happening when that grain enters the water is completely real. Water genuinely moves in response, according to the same conservation laws governing every other physical interaction in the universe. But the scale mismatch between one grain of rice and an entire ocean renders any resulting tidal change functionally undetectable, indistinguishable in any practical sense from doing nothing to the ocean at all. Or picture a stadium packed with 80,000 fans, all stomping their feet in unison, trying to physically move the building's foundation through sheer coordinated force. The stadium does technically vibrate in response, because the combined force from 80,000 simultaneous footfalls is real and measurable at the structural level. But the stadium's own mass, built from steel, concrete, and earth foundations, so vastly exceeds the crowd's combined force that no actual structural displacement occurs, beyond ordinary harmless vibration that any engineer would consider completely unremarkable. Even the largest verified, deliberate, synchronized human physical events in recorded history, involving far fewer participants than the global population, have produced zero measurable seismic or orbital effect on Earth. This isn't a theoretical prediction waiting on a real-world test. It's a prediction that's already been effectively confirmed by every large stadium event, every mass gathering, every coordinated flash mob that's ever generated ground vibrations too small to register as anything beyond routine background noise on seismographs already monitoring the area. There's something genuinely humbling buried inside all of this, and it's worth sitting with rather than rushing past. The single largest number of coordinated human beings that could ever theoretically act in perfect unison, every person on the planet doing the exact same thing at the exact same instant, represents the absolute ceiling of unified collective human physical action. There's no larger coordinated act available to our species than this one. And that maximum possible effort, at its absolute peak, produces a result on the planet we live on that is, in every meaningful physical sense, indistinguishable from nothing happening at all. That's not a depressing fact, it's a clarifying one. Humanity's collective physical force against Earth itself is genuinely, measurably negligible, and understanding exactly why reveals something real about the actual scale relationship between human bodies and planetary bodies, a relationship that has nothing to do with how impressive 8 billion sounds as a number, and everything to do with mass ratios that dwarf even our biggest, most imaginative attempts at collective action. Conservation of momentum applies universally, without exception, to any interacting system of objects, whether that system involves subatomic particles colliding in a laboratory or planets and moons interacting across millions of kilometers of empty space. What varies isn't the law itself, it's the mass ratio between the objects involved. And that ratio is what ultimately determines whether an interaction produces a dramatic, visible effect, or an effect so small it evaporates below every threshold of detection humans have ever built instruments to measure. This mathematical relationship has held for over 3 centuries since Newton first formalized it, and it remains true regardless of how large a human coordinated effort ever becomes. No future gathering, no larger global population, no more perfectly synchronized countdown will ever meaningfully shift that mass ratio, because the ratio depends on Earth's mass staying roughly constant, while humanity's combined mass, even at some future population size, remains a rounding error too small to register against a number measured in the tens of septillions of kilograms. Future seismometer networks, more sensitive than anything currently deployed, will keep improving their ability to detect smaller and smaller ground vibrations, tracking earthquakes down to increasingly minor magnitudes with increasingly precise instrumentation. They will never detect a synchronized human jump as a distinct signal, no matter how many people participate or how perfectly they time it, because the theoretical displacement sits so far beneath atomic scale that no amount of instrument sensitivity closes a gap measured in trillions, not percentages. The planet beneath your feet was never going to notice, and it never will.